so easy. After that, this computer, okay, 192.168.111. Let me check the connectivity between these two PCs from the PC1. This is the PC from PC0. This PC now can send traffic in command prompt 192.168.111. Okay, and here you can use -T, means repeated ping. I'm going to continue the sending ICMP echo request. As you can see, we have connectivity. Now, I want to show you what is happening when we are adding one link here. Let me to show you. Look at here. I'm going to add the fast Ethernet 01 to the fast Ethernet, for example, or fast Ethernet 02. Okay, here we use gigabit 01. Okay, it's okay. We can use, for example, in the previous example, we use gigabit. Okay, it's important. It's not important. Gigabit 02 to gigabit 01. Look at here. After adding this interface, first, the fast Ethernet 02 should change immediately to the block, as you can see. Now we don't have any pass between the PC0 and PC1 because these two interface, gigabit 02 and gigabit 01, now is, for example, passing from the state of listening and learning. Let me to show you here in the switch tree. Show a spanning tree can show us that the port gigabit 02 now has the learning state. After some second, we will have connectivity. Look at here. We need to wait. Now this is forwarded. As you can see, now we have connectivity. This means that about 5 timeout, or maybe a little less or a little more, we have this connectivity. This is because the listening and learning state in this scenario. Very good. Until now, you learn about the states that we are experiencing, but maybe you ask me what is happening in the learning state. Okay, you know that in learning state we need to modify the for example tables, modify the MAC address tables. Maybe you ask me what is happening in the learning state that the MAC address tables are modifying. Let me to talk about a little more than this, about this, for example, feature. Maybe some of the information that you are learning now is beyond the scope of CCNA. It's okay, because you should know everything completely. All right, the question is, what is happening in the learning state? Let me to talk about that, but for now, for a start, let me to say that in STP, actually, we have two types of BPDU. The first type of BPDU is the configuration BPDU, and this BPDU is exactly the BPDU that you have learned until now about that. Because of that, you have learned about the configuration BPDU until now. But we have another type of BPDU in STP, in traditional STP. We call it TCN BPDU, or briefly TCN. Okay, TCN is the abbreviation of the topology, okay, change then notification. Okay, topology change notification, or TCN. Okay, what is the function of TCN? You know that we learned about the configuration BPDU. Now I'm going to talk about the TCN BPDU, the new type of BPDU that you are learning about that. Okay, what is the function of the TCN BPDU? If you want to understand the function of this BPDU, you can again repeat the process that is occurring when, for example, the link between the switch 1 and switch 2 is, for example, connecting to switch 1 and switch 3. Okay, the link between switch 1 and switch 3 is connecting. Look at here. Now we are working in a steady state. This interface is the root port. Okay, let me to show you what is happening when you are adding this link, the port 2 to the, for example, port 1 of the switch 3. You know that the first thing that is happening is the advertising the BPDU, okay, the configuration BPDU. Let me to write here, because now this is important. Configuration BPDU from the switch 1 to the switch 3. Why? Because you know that before than this link we had the role of disable. Okay, now we have the role of DP, and because of that in DP we should send BPDU. You know that now we are residing in the listening state. Okay, we can send BPDU. Configuration BPDU include the root bridge ID, BID1, okay, then sender bridge ID, BID1, and then root pass cost 0, and then sender port ID equal 128.2. okay, we are sending this BPDU to the switch tree. You know it. Okay, this is only the repeat of the process that you learned before. Okay, and after that, you know that immediately switch tree can understand that the role of this interface changed from the disabled to the root port, and it should go to the listening state. Because of that, this interface now has the new role of the alternate or block, and after that we need to immediately blocking this interface. That's it. Okay, and after that, as you can see, now the switch 1 understand that a change occurred in this network. So you know that the switch 1 is the root bridge, and the root bridge is the only switch that can send the BPDU. Okay, in the BPDU of the switch 1, we have a field, we call it TC, not TCN. Don't mistake this with TCN. This is TC, means topology change. I will talk about the TCN. Okay, TC is a flag in the BPDU. Okay, in BPDUs of the switch 1, we have the TC bit set by 1. This means that now we are setting TC bit, and you know that the BPDU that is sending from the switch 1 to the switch 2 now contain this TC bit 1. I will talk about the function of this TC bit, and after that, here also, when the switch 1 sending the configuration BPDU, okay, to the switch 2, this is the configuration BPDU in that is sending from switch 1 to the switch 2. BID RBID is BID1, SPID is BID1, RPC is 0, sender port ID is 128.1. okay, again we have the TC bit, and also finally the BPDU that is forwarded by switch 2 to switch 3. okay, BID1, then sender bridge ID is BID2, root pass cost is 4, for example, and the sender port ID is 128.2. we have this TC bit. Okay, after that, until now you don't know about the function of TC bit, but you know that now the TC bit is was set. Why? Because the switch 1 as a root bridge knows about the change. And after that, this interface now is residing in listening, and also this interface, the port 2 of switch 1, is residing in listening. Because of that, after 15 seconds, okay, you know that after 15 seconds we need to modify our tables. Okay, when you are receiving the for example, when you are experiencing a change, for example, adding one link, or for example removing one link, the switch 1 and switch 3, both of them know about the change. Because of that, they can remove or flush their entries from their MAC address table, but the switch 2 doesn't know about the change. With TC bit set, the switch 1 can say to switch 2, can inform to switch 2 that a link change means changing from block to forward, or forward to block in one side of the network, okay, is occurred. You need to flush your MAC address table. Okay, you know that, but look at here, we added the link between switch 1 and switch 3. Because of that, both of them know about the this change. They can flush their MAC address table. Okay, you know that because the MAC address table should be changed. All of the entries in the MAC address table should be changed. But the switch 2 and other switch that are residing here, okay, don't know about the change. With TC bit, not TCN, until now I didn't talk about the TCN. With TC bit, we can inform all of the other switches that you should, okay, all of you should remove the entries or flush the entries of the MAC address table. After that, with the new condition, you can learn the MAC addresses. Okay, because of that, when we are receiving TC bit in switch 2, we can flush the MAC address table, and step by step we can learn again the MAC address table with new condition with this link. Because now, for example, PC3, before then this link, it was learned on the port 2. Now the PC3 should learn on the port 1. Okay, because with this pass we have reachability to the PC3. Okay, and also here in the PC tree, we need to wait, for example, 50 seconds in the learning state, okay? And after this 15 seconds, we can ensure that all of the MAC address tables on all layers of the network